understood or not, it was obvious that the American democratic system does not work. Okay, but that's okay because it worked for me and I was okay with that. All right. So that's my cop story. I'm going to tell you guys another cop story. You guys ready? You have your notes out? Okay, we're going to finish up our notes. Okay, and this is another cop story. Okay, there's a cop standing right here. Okay, oops, let me draw a cop. Okay, and he's trying to catch people ticketing. He's trying to catch people speeding. Okay, and there's a car right here. Okay, and this car is going 50 miles per hour. The speed limit, what does it say on your paper? What's the speed limit? Is it 60 miles per hour? So the speed limit is 60 miles per hour. Okay, this car is going 50 miles per hour. Is he speeding? No, because he knows this is a speed trap. He passes the cop and he's going 50 miles per hour. He slows down for the cop, okay? But you know cops, they always have their friends down the road, right? And their friends, what will happen is if they don't catch you here, they'll catch you down here, right? If you speed here, they'll call their friend down the road and he'll get you, okay? But this is a smart car. So when he pulls down to this cop here, it's the same car. It's just a different color because I picked the wrong color down here. Okay, but it's the same car, okay? He slows down to 50 miles per hour here when he gets to this cop over here. The distance between these two cops, what does it say on your paper? Is it 4 miles? Is that right? The distance between, is it 4 or 5? Okay, it's 5 miles. So the distance between them is 5 miles. And we know that, and this is a given, we know that it takes 4 minutes to get from here to here, okay? And I want you guys to think about, remember when we did Usain Bolt? And we said that we knew that in 9.58 seconds, but now we're talking about 4 minutes. It took him, was it 100 meters, right? The 100-meter yard dash? Okay, but we're not going 100 meters, we're going 5 miles. So this is the same as the Usain Bolt graph, okay? But instead of 100 meters, we're doing 5 miles. Instead of 9.58, we're doing time is 4 minutes, okay? So on average, how long did it take this car to go 5 miles in 4 minutes on average? Isn't that just the slope of this line on average, right? The slope of this line. Because if we said on average, how fast did Usain Bolt go, right? We just said 100 meters divided by 9.58 seconds. And we can get the average speed. So on average, how fast is this car going? About 5 miles per every 4 minutes. It took 4 minutes to go 5 miles. And you've done this in physics, right? Position, distance, over time. Okay? Well, let me change that to miles per hour because miles per minute doesn't mean a lot to me. Okay, so that's going to be 60 minutes in 1 hour. You agree with that? Okay, so that's going to be 300 miles for 4 hours. Okay, if I do 300 divided by 4, I think that's 75. So on average, this car went about 75 miles per hour on average. Sometimes he might have been faster, sometimes he might have been slower. You guys good with that? Just like Usain Bolt. But on average, he went 75. So the real curve that this car drove was actually not always this steep, right? He wasn't always going 75 miles per hour because when he passed the cop, he was going a slower slope than that. You agree with that? And then he probably sped up in the middle somewhere, maybe multiple times. But then when he passed the next cop, that slope went back down. Do you agree with that? So this red line is more of what this guy in this red car that turns green went, okay? So this is actually mean value theorem, guys. Think about it. On average, the slope, this is the slope of the secant line. Do you see this blue line? That's the slope of the secant line. That's 75 miles per hour, okay? MVT, the mean value theorem says that if you have a continuous function, this red line's continuous, and you have a differential function, this red line's differentiable, okay? If you go take your tangent line, remember your tangent line, what'd you guys do with it? Anybody get a new boyfriend or girlfriend? It didn't work? Well, I had no promises there, okay? So if you draw your tangent line and you bring it around here, remember what MVT says that at least how many points? At least how many times? At least one time, you're gonna be equal to this, the slope will be the same as this blue line. So at least one time, this guy must have gone at least how fast? 75 miles per hour, at least once, maybe more than once, okay? So at least once he went 75 miles per hour. So this cop can ticket this guy. This cop can say, hey, you went 75 miles per hour. We know you did. And the guy could say, no, there's no way you know. I was going 50 when I passed this cop. I was going 50 when I passed this cop. But this cop, if he knows calculus, okay, he's got to know calculus though. If he knows calculus, he can say no by MVT, okay, because the function is continuous on the closed interval and because the function is differentiable on the open interval, this red line here is the function, okay, then we know that at least one time, okay, you went, at least one time you went 75 miles per hour, okay? Now let's say this driver is a fool, okay, and he argues with a cop. You should never argue with a cop, okay? He says, no, there's no way you can give me a ticket, okay? You can't prove it, okay? So then the cop calls his friend, he calls his brother, okay, he's really good at calculus, and he says, give the guy 2 tickets. Can he give him 2 tickets? Well, let's think about this. We talked about MVT, okay, and for sure he went at least 75 miles per hour at least once. But guess what? If I graph t versus velocity, okay, and you wouldn't know this except I told you, but this is kind of an interesting story to look at. At time when he passed the first cop, so whatever time that was, we'll just call it time 0, okay, he was going 50 miles per hour. Do you agree with that? The time when he passed the second cop, I'll call that 4 minutes, okay, because it took 4 minutes to go from here to here. He passed the second cop. How fast was he going? 50 miles per hour. Remember when I was driving in my Porsche and I told you guys, I looked at my speedometer and I knew I passed a certain number, okay? Well, we know because of MVT, okay, we know that at some point he hit 75, right? We know that because of MVT, okay? And so that's at some time. We don't know what time it is, but it's between 0 and 4, okay? But the reason you knew that I hit 100 miles per hour in my Porsche was because you knew that velocity is what kind of function? Continuous function. Velocity is a continuous function. Guys, what's the speed limit? 60. Did I ever hit 65 here? Yes. Did I ever hit 65 here? By what theorem? IVT. Very good. Okay. So IVT says I actually hit 65 twice. So can he ticket me twice? Yes, he could. He could. Not a very nice cop, okay, but he could ticket me twice because by IVT I did hit 65 twice. By MVT I did hit 75 once. Okay, so it's kind of an interesting problem. I'm never going to ask you this, but this is actually a very common problem that teachers will use to introduce students to how MVT relates with IVT. Okay, and they are related. Kind of a strange relationship, but they are. Okay, let's go back to your homework. How many of you guys tried your homework last night? Did? Okay, let's talk about questions then. What questions do you guys have? And I copied some homework here. Which one? Number 1. Did you get past number 1, Alexis? Okay, let's look at number 1. Okay, is it this one right here? Okay, this one just says, hey, look at the graph. Let me see if I can pull this graph here. Yeah, go ahead. This one says, look at the graph. It's exactly what you did with your toothpick. It says, look at the graph, go to -4, go to 4, draw a secant line. Does that make sense? Okay, then take your toothpick, put it on the blue curve, and mark a C every time your toothpick is parallel. So I'd mark a C there. I'd probably mark a C somewhere here. And that's it. Those 2 C's would be your answer. I don't know what the multiple choice says. I don't have it with me. Okay, so you're good? Does that make sense? Okay. Yeah, that's what they're asking you. Okay, let's do another question, guys. Number 2. Are we just going to work through this in order? Okay. This is a sin x2 one. Guys, tell me the truth. Why didn't you do this problem? Did it have anything to do? It had to do with Greeks? Okay. Okay, here we go. This says MVT already applies. Okay, so we don't have to prove that it applies. All we have to do is write it into the formula. Okay, guys, write the formula for MVT first. Okay, it's the slope of the tangent line is equal to the slope of the secant line. Okay, and so here's my f of x. Okay, so I'm going to take the derivative of this. What's the derivative of sine u? Okay, I want the derivative of sine u. Is it cosine u du dx? Okay, I'm going to pull the u out a little bit. I'm going to bounce it out. So it's really d dx of u, but that's the same as du dx. Okay, is equal to. Now, what's my a and what's my b in this problem? A, okay. So I'm going to plug that in. So here we go. F of 3 pi over 2 minus f of pi over 2 over 3 pi over 2 minus pi over 2. Okay. What's my u in this problem? It's sine u. So what's my u? X over 2. Now here's a question. What's the derivative of u? What's the derivative of x over 2? Bounce that x out. Bounce that x out. It'll be easier. It's 1/2, right? So this right here is just 1/2 times the cosine of x over 2. Okay, let's look at the right side. The right side, you want to plug into all these things, but you really don't want to do it right here. If you do, it's going to get really, really ugly. So I'm going to pull to the side of my paper. Okay, so let me pull this more to the left so I have more paper. And I'm going to figure out what f of 3 pi over 2 is. Okay, what's f of 3 pi over 2? All right, I'm going to plug into f. Now, we got to clarify what f is. Is f the same thing as the derivative, or was it the original function? It's the original function. So I want to go find the original function, which is right here. And everywhere there's an x, I'm going to put in 3 pi over 2. This is 3 pi over 2 all over 2. Okay. Remember what we said about numerators? What do? They bounce down or bounce out. So this will be sine of 3 pi over 4. Can you guys do that? Do you guys see where I got the 4? Because it bounces out and then everything multiplies. Okay. Guys, it's the exact same thing as dividing fractions, easy as pi, flip the second and multiply. You can do it both ways if you feel uncomfortable with bouncing out. Okay, then you need to know the unit circle. Where is 3 pi over 4? Okay, what is the sine value of that? Square root of 2 over 2. Okay, so this right here, guys, is square root of 2 over 2. So I'll put that right there. Okay. Now, the other value I need is f of pi over 2. Okay, what's f of pi over 2? Well, again, I go find my f. Everywhere there's an x, I'm going to put in pi over 2. So this will be pi over 2 all divided by 2. What do numerators do? They bounce out. So this is equal to pi. Oops, I forgot my sign. I'm sorry. It's the sine of pi over 2 all over 2. So this will be sine of pi over 4. Good. And then on your unit circle, okay, where is pi over 4? Top right, okay. What's the sine value right there? Root 2 over 2. So what I have is this right here, this is root 2 over 2. Do you see I get 0 on the top? I don't know if you see that. Root 2 over 2 minus root 2 over 2. I can write it for you guys. This is root 2 over 2 minus root 2 over 2. That's a minus sign. Divided by, this is 3 pi minus pi. So that's 2 pi over 2, right? So 2 pi over 2 is really just pi. But it really doesn't even matter because what is the numerator? 0. So do you guys see that that's just 0? Okay, now be careful. My answer is not 0. So a lot of students will stop right there and they'll be like, oh, yay, I'm done. Okay, why am I not done? Yeah, all I did was find the slope. I just found the slope of the secant line. That's all I did, okay, which actually is equal to the slope of the tangent line in at least one place. That's what MVT says. It's equal in at least one place. But the question wasn't, what's the slope of the secant line? The question is, what is my x? Are you guys good with that? The question is solve for x. And I know that it's actually a c. So if you guys want, you can come through and put c's everywhere you see an x, okay? But I just solve for x because I'm more comfortable with x. So what I get is 1/2 cosine x over 2 is equal to 0. And my goal is to solve for x. All right, how do I get rid of this 1/2? Multiply by 2 on both sides. And do you see if I multiply by 2, it really just disappears. Is everybody good with that? Okay, now this is where students have trouble. And I just want you to think of this as a blob. This is a big blob. What does this blob have to be in order for cosine of that angle to equal 0? What does this have to be? Think about your cosine. What angle is your cosine value 0? Pi over 2, and where else? 3 pi over 2, okay? So this blob, whatever it is, okay, whatever this blob is, it's got to be equal to pi over 2, or it's got to be equal to 3 pi over 2. Does that make sense? But we know what the blob is. The blob is actually x over 2, okay? So this is x over 2 must be pi over 2, or it must be 3 pi over 2. And our goal wasn't to solve for the blob. Our goal is to solve for what? X. So I've got one fraction on the left, one fraction on the right, and equal sign in the middle. So this will be 2x is equal to 2 pi. So therefore, x is equal to pi. Over here, 2x is going to be equal to 6 pi. So x is going to be equal to 3 pi. And those are my answers. But you always have to check, guys. Be careful. I promise you on the test, there'll be multiple choice. And there'll be a multiple choice where both of these are in the answer. And there'll be a multiple choice where only one of them is in the answer. Okay? You got to check to make sure it's inside your endpoint. Okay? What were my endpoints here? Was it pi over 2 and 3 pi over 2? Okay. It could be both of them because you have, but the thing is you're guaranteed to have one, at least one. So is it both or one? One. It's just the x equals pi. And this one is too big to be inside that interval. Okay? Does that make sense to you guys? All right, let's do another one. What other questions do you guys have? Are you joking? Okay. Are you seriously joking? I feel like, okay, good. Because I feel like that one you actually might want to try yourself. The x plus 1 over x1, that might be a little tougher. Okay, yeah, let's do this one, number 4. Okay. Actually, let's do the graph. Even before we get started, the graph I feel like is, sometimes it's confusing because they give you so many choices, but it's actually not very hard. Remember, it's just like your toothpick problem, okay? So first you draw the picture, and if you look at your choices for your graph, all the graphs have the same picture. You good with that? So you don't have to worry about what does the picture look like, is it right or wrong? Okay, for this problem, all the pictures are the same graph. Okay, so now you just have to draw the secant line. So you have to go find these points, -6 and -2. Find those 2 points and connect them. So here's -6, here's -2, and you connect that line. So there, that red line there is that. This one's connected, that's the red line, and this one's connected, that's the blue line. Okay, everybody sees the secant line. Then what you do is you take your toothpick and go along the blue curve, okay? And every time your toothpick is parallel to this red line, or parallel to the green line, you're gonna put a dot, okay? And so here's a dot here, and this dot here, there's a dot here, and there's a dot here. But remember, when you drew your dot, you had to be between your A and B. Does that make sense? And so in part B, they put a dot that wasn't between their A and B. You see that? So that's why you would eliminate B. And then C, I don't see a dot at all. Does that make sense? So C, they didn't even draw that. You know how you went through and you put a C wherever the slope was parallel? And so I think the answer is A, because C doesn't even have a dot. Okay? So whenever they ask you for a graph, guys, it really is the exact thing that you were doing with the toothpick. All right, so let's look at how to do this problem. I'm going to delete this now that we've dealt with the picture. Okay, please first determine whether MVT applies. Okay, so you got to figure out if the function is continuous and differentiable or not. This one, if you think about what x looks like this. You agree with that? That's y equals x. Okay, and what does 1 over x look like? Think about what 1 over x looks like. You guys remember this? This is 1 over x. Okay, the key though is they're telling you to look at this interval, -6 to -2. So -6 to -2, do you see that it'll always be on this left side of the graph? -6 to -2, okay? And if this part is continuous and you add it with something that is continuous and differentiable, okay, just letting you know, then it'll also be continuous and differentiable. Okay, so just letting you know, if something's continuous differentiable and you add it to something that's continuous and differentiable, it'll still be continuous and differentiable. Okay, and so that's what we're doing. It is continuous and differentiable, so check. Honestly, if you're not sure, you can just say it is and just keep going. Does that make sense? If you're not sure, you'll just get it counted right, wrong, if you didn't have to do it at all, okay? But what we have to say is the function is first continuous over the closed interval, okay? And the second thing you have to say is the function is differentiable on the open interval, okay? And so the functions that I'll give you guys that are not continuous and differentiable, they're the ones that we went over on the first day of MVT. Do you remember that yesterday? I went over like 5 different parent functions that you have to know. It'll be one of those, okay? So make sure you know those. Those are the ones I'll give you that are not continuous or not differentiable. All right. So once you do this, this is actually part A right here. Okay, make sure you do brackets here for continuous and parentheses here for differentiable. Okay, then what you want to do is find the points that are guaranteed. Okay, so when you find the points that are guaranteed, what you do is you set the derivative equal to the slope of the tangent line. You just really memorize this formula. And remember, this formula is not true all the time. It's only true at least one point. Okay, so let's go ahead and take the derivative of this. On the left side, what's the derivative of, and I'm going to change this function, rewrite it, x plus x to the negative 1. What's the derivative of that? 1, right, minus x to the negative 2, okay? What's my b and what's my a? Which one are you going to call b and a? Honestly, it doesn't matter, but I usually am pretty consistent about calling the first one a and the second one b. Whatever you do, just be consistent about it and you'll be fine. Okay, so this will be f at negative 2 minus f at negative 6 all over, okay, b minus a, which is negative 2 minus negative 6. Be very careful with these negatives. Okay, all right. First, what I'm going to do is I'm going to find f of negative 2. So pull to the side of your paper and find f of negative 2. Okay, don't do it right in there because you're going to lose this negative sign, I promise. At some point you'll lose it and you'll be in trouble. So find f of negative 2. Okay, here's a question. What do I plug negative 2 in? Do I plug it into the function or the derivative of the function? The function, because it's f. All right, so I'm going to plug it into x plus 1 over x. So that's negative 2 plus 1 over negative 2, which is actually negative 2 minus 1/2, which is actually negative 2 to the 1/2. Everybody good with that? Okay. If I turn this into an improper fraction, if I needed it, it's negative 5 over 2. Okay, let's do f of negative 6. Okay, that's going to be, plug it into x plus 1 over x. So everywhere I see an x, I'm going to put in negative 6. So it's negative 6 plus 1 over negative 6. Okay, what is that equal to? Well, isn't that negative 6 minus 1 over 6? And isn't that really negative 6 to the negative 6 plus 1/6? And if I turn that into an improper fraction, that's negative 37 over 6. Okay? All right. So right here, let's go ahead and plug in. What I'm going to get is f of negative 2. Let me pull this down. Okay. So I have f of negative 2 is going to be negative 5/2. I'm going to subtract. Subtract what? Subtract negative 37 over 6 and divide that by 2 minus negative 6, which is 4. Hopefully that's right. On the left side, I'm going to change this because this is unsimplified. So how do I make it simplified? Because I need to solve for x eventually, right? Okay. How am I going to add these two fractions up here? What's the common denominator? Is it 6? So I'm going to make this times 3 times 3. So negative 15. This is a minus minus. Change that to a plus. So that would be plus 37 over 6 all over 4. The numerator is going to be 37 minus 15, which I think is 22. 22 over 6 all over 4. Okay, you guys with me so far? Okay, and so let me show you what a lot of students do. They do great on the right side. So this is going to be 22 over 6. You guys okay bouncing that down? 22 over 6. So that's really 22 over 24, right? Okay, and then what students would do is they'll box it in. They'll be like, yes, that was a multiple choice, so I must be right. Is the answer 22 over 26? No, I've only done the right side of the problem. Guys, don't forget to find x. The goal was to find x. So this is really 1 minus 1 over x squared equals 22 over 24. You need to solve this problem, not just the right side, okay? I know someone's going to do that, so I'm warning you guys ahead of time. All right? Okay, so right here, guys, how do I solve for x squared? Here's just an algebra problem, but how do you do it? I need to get x squared by itself. Okay, subtract 1 on both sides first. So this would be negative 1 over x squared equals 22 over 24. If I subtract 1, do you agree that's subtracting 24 over 24? Right? Okay, so that's going to be negative 1 over x squared equals negative 2 over 24. You guys okay if I reduce the right side? That's actually going to be negative 1 over 12. Okay, what's next? What's x squared going to be? Can I cross multiply? Yes, I have one fraction on the left, one fraction on the right, and an equal sign in the middle. So I'll go ahead and cross multiply. I'll get negative x squared equals negative 12, which really means x squared equals to 12. Okay, so x is going to be plus or minus the square root of 12. Okay, if you simplify that, and I don't think, for me, you don't have to. I don't know how my math lab is, but that's really the square root of 3 times the square root of 4. So that's actually equal to 2 square root of 3, plus or minus. Okay, if you box this in and you go find it on a multiple choice, it will be on the multiple choice, but it will be wrong. Why? I found x. It's got to be inside the what? Interval. Okay, so go back and look at your interval. What was my interval for this problem? Negative 6 to negative 2. So this has to be which one? The negative one. Okay, you guys can check to make sure it's inside the interval, but you got to pick the number that's inside the interval. Okay, yeah, Eric. For your test, it will be. I don't know how picky my math lab is, depending on the question. Yeah. Okay. Any other questions? All right. You want to do any other problem together? Even on the Extrema homework, the homework before. Yeah. On last night's homework, or the one before? So this one right here? Okay. You're supposed to do a candidates test here. Okay, so this is a review, guys. This is absolute, max, and min. Okay. So what I'm going to do is I'm going to set up an x and f of x. All right. Guys, what do you always put in the candidates test? Your endpoints. Okay, put in your endpoints and your what? Critical points, right? Your critical points are found where all the relative maxes and mins are. Okay. And so the way you find that is you take the derivative of this and you set this derivative equal to 0, and you set this derivative equal to dne. And all the possible x's that you can find, okay? You collect all of them, okay? And you put them into this candidate test, all right? So let's find all the x's we can find. So let's take the derivative. The derivative of f of x would be 4/3. Leave the inside alone, leave it alone. Take the power down by 1. So do you see that that would be 1/3? But don't forget to take the derivative of the inside. The derivative of x minus 3, you guys see, is just 1. Okay? So if I simplify this, this is really 4/3 x minus 3 to the 1/3 is equal to 0. And I also set it equal to dne. Okay, this is really messy, so let me try to rewrite it. Okay, so what I'm trying to figure out is when this thing will equal 0. This 1/3 is really hard to understand what's going on here. Actually, before I even start, are you guys okay if I multiply both sides by 3/4? Because I can just get rid of the 4/3 by doing that. I don't know if you're comfortable with that, but you know, no matter what number this is, I can multiply that on both sides because it has a 0 on this side. Okay, so this is really the cube root of x minus 3 is equal to 0. So how do I get rid of a cube root? I cube it. So I multiply this by, or I raise it to the 3rd power. I raise this to the 3rd power. So I get x minus 3 is equal to 0. But what does that mean x is equal to? 3. Okay, so that's one critical point. I'll put CP there. Okay, it's a critical point. But I can find more critical points if I go set this equal to dne. Okay, so I go over here and I look at this problem and I say, in the denominator, first of all, make sure it's simplified, meaning all the exponents are positive. and exponents are positive, okay? So what I do is I say in the denominator, is there any denominator I can set equal to 0? Because if the denominator is 0, then this thing will explode. This thing will be undefined, okay? But do you see that this fraction bar is actually like this? I don't know if you see that, because just like numerators bounce out, things that are bounced out can go back to the numerator. Does that make sense? Okay, so if I put this back in the numerator, the only denominator I have is 3, and I'll set 3 equal to 0. That doesn't give me any critical points. Okay, that 3 equals 0, that's just silly. Okay, so on the right side, I get no critical points. So doing all this work, I actually only got one critical point, and that was 3. I make sure it's between -7 and 7, though. If it's not, then I would just use -7 and 7. That's it. There are no critical points. Yeah.
So if you want to get a critical point for when you put this for 0 and there's only one point,
oh yeah, I guess so. That would be, yeah, that's kind of cheating, but yes, Eric, the answer is yes. Yes. Okay. Over here, what's f of x? How do I figure out f of x? Now be careful. Do I plug it into this function here, or do I plug it into this function here? There are two things to plug it into. The top one. You guys good? F of x is up here. So I'm going to put in -7. So this will be -7 minus 3, which will be -10 raised to the 4/3. Okay. If I plug in 3, I'll get 0 raised to the 4/3. This one's easy. That's 0. If I plug in 7, I'll get 4 raised to the 4/3. You guys okay? I didn't put out all my work here, but what I'm doing is I'm just plugging in right here, this x right here. Okay. What is -10 raised to the 4/3? It is actually something positive because I'm going to square it and then square it again. I actually think this one's going to be the biggest number right here. You guys can use a calculator to make sure, but I think this one's going to be the biggest number. Okay. So I need to figure out what's the max. So the max is equal to this number right here, -10 raised to the 4/3. And that's going to happen at what point? X equals -7. Do you guys see why I know that this one's going to be the biggest? Because -10 times -10 times -10 times -10 is going to be positive 1,000 or 10,000. I can't do that in my head, but 4 zeros, 10,000. Okay. And so, and I've cube root that. This would be 4 times 4 times 4 times 4, and I cube root that. So this one would be smaller. But what's the smallest number here? 0. And where is that going to happen at? 3. Okay, so that is your answer. Okay. My math lab might be a little picky about this, so try to put it in with the parentheses exactly like this. Okay, yeah. Yes, you can. And if you want to change it to decimal, you can too. But if you do change it to a decimal, make sure you give me three decimal places. Okay. All right. Any other questions? Did we just
Ms. Chang?
Yeah, Clary? Yes, I think you will. I'm not 100% sure though. There's some things that I want you to use a calculator for and some not. So I think what I'll do is I'll give you a quiz before the test, and that quiz may or may not have a calculator, and then the test may or may not. Like one will have a calculator and one will not. Okay. Yeah. All right. Someone online has a question, I think. Online, do you guys have a question?
Ms. Chang, can you do number 8?
Yes, number 8 on last night's homework. Okay, guys, let's look at number 8 on last night's homework. And if you guys have already done this, feel free to work on other problems. Okay, just don't waste time, please. All right, so this is number 8. And this says mean value theorem already applies. Okay, when it says it already applies, that means you don't have to say the function's continuous on the closed interval, the function's differentiable on the open interval. Okay, if it already applies, then you just move right into MVT. And what is MVT? It says there is at least one point, okay, where the derivative is equal to the slope of the secant line. It doesn't mean it's always true. Actually, the only one time when it's always true is if your function is a line. They would always be true. But most of the time it's not. So then what you do is you take the derivative of the left side. So here's my function. I know it says h, but I'm just going to call it f because it's easier for me. Let's take the derivative of this. This will be a quotient rule. So it'll be the derivative of the first times the second minus the derivative of the second times the first all over x minus 4 quantity squared. That's the quotient rule, okay? What is that equal to? That's equal to f of b minus f of a. So I got to go find my a and my b. You guys good so far? Okay, so every time there's a b, I'm going to put in 3. Every time there's an a, I'll put in 0. So this will be 3 minus 0. Then I'm going to go to the side of my paper, and I'm going to go figure out what f of 3 is. Okay, then I'll plug it back into here. So f of 3, make sure you plug into f and not plug into the derivative, okay? So f of 3 is everywhere there's an x, I'm going to put in 3. So that gives me 3 over negative 1, which is really negative 3, right? Okay, then what's f of 0? Everywhere there's an x, I'm going to put in 0. So this will give me 0 over 0 minus 4, and that's 0 over negative 4, which is 0. Okay, so let me plug in here. This will give me negative 3 minus 0 over 3, which will actually just give me negative 1. Okay, and then what students do, they box this in, and they're like, yes, I got the answer, and guess what? There's a multiple choice that says negative 1, and so that must be right. Am I done with the problem? No. What do I need to do? Yes, I need to plug it back in. I need to solve for x. Okay, so this problem really is, let me just go ahead and distribute this. This will be x minus 4 minus x over x minus 4 quantity squared is equal to negative 1. Okay, this is the problem I want to solve. I did not want to just solve the right side. I've only found, this is just the slope. That's all I found, okay, if I did that. All right, so let's keep on solving for x. X minus x is 0, right, guys? So this is just 4 over the quantity x. Oh, yeah, you're right. Thank you. Negative 4 over the quantity x minus 4 quantity squared equals, and then this is negative 1. Okay, any suggestions? Okay, you can cross multiply if you have a fraction on the left and a fraction on the right and an equal sign in the middle. Okay, so let's go ahead and cross multiply here. I'll get negative. Let me do the x first. I'll get negative quantity x minus 4 squared is equal to negative 4. Now this is a little awkward. Are you guys okay if I multiply by negative 1 on both sides? Okay, or divide by negative 1. That way I get rid of all these awkward negative signs. Okay, some of you guys are okay with being awkward. I'm actually okay with being awkward, but not in math. Okay, so this is what I have. Any ideas on what to do next? I need to solve for x. You could square root both sides. Now there's a little bit of a danger if you square root both sides. Just make sure, if you do square root both sides, make sure you understand the left side is x minus 4, but the right side is actually plus or minus 2. Okay, if you square root both sides, make sure you do that. So those of you guys who want to square root both sides, you can take it from there. I'm gonna, not that that's wrong, but I'm going to go ahead and factor out. Okay, just so you guys can see. If I factor this out, I actually get something that's factorable. This is x squared minus 8x plus 16 equals 4. If I move the 4 to the left, I'll get this. And I can use 6 and 2 here for the 12. So this will be x minus 6, x minus 2. Okay, both ways are right. I just want to say this way, if you forget that the square root of 4, when you have an x squared is plus or minus 2, then this way will help you more. Okay, Maddie, you're with me on this? So right here, have you done this problem, Maddie? Okay, good, thank you. All right, this is going to be x is equal to 6, and this is x equal to 2. Okay, and so why did I even do all this? What kind of problem is this? This is an MVT problem? Okay, MVT. I was trying to figure out if this is a candidate's test or not. Okay, it's MVT. So you want to find the one that is inside your interval, and I'll let you guys pick that. Okay, you guys can take it from there. Are you guys feeling good?